Yes. Okay. Shomojit, please start recording.
Okay. Now the video is start to record.
Okay.
Please check it.
Okay.
Shall I start, sir?
Yes. You start, please.
Okay. Good morning, everybody. This is Priksha Vishwas, and I heartily welcome you all in this special lecture series organized by the PG Department of Geography, Cooch College. As we all know that it is a critical pandemic situation and we all are facing a long time lockdown and closure of every educational institution. Yet we hope a multi-dimensional special lecture series can remove all the barriers and overcome our boredom and fatigues. Please pardon me for my bad throat.
Sound is low. Please come. Okay.
Okay, sir. Sir, now is it okay?
Yeah, it's okay.
Okay, sir. So keeping in this mind, to encourage our students, research scholars, and various faculty members with a bird's eye view on upcoming NAC assessment of Cooch College, our department has organized a series of special lectures and webinar by its own trust. And today in this special lecture session, we are lucky enough to get our two most eminent respected professors, Dr. Sujit Mondal and Dr. Ramkrishna Maiti, in between us with a huge number of participants from different colleges, research groups, dear students, faculties from our college and other colleges too. And I hope that our participants will be interested to learn the new ideas from the field of geography. And on behalf of my department, the Department of Geography, Cooch College, I again cordially welcome you all in this virtual platform of knowledge sharing. I also hope to make a successful learning ahead. And in this connection, with all my regards now, I would like to invite our respected Sir, Dr. Tapan Kumar Dash, the convener and coordinator of PG Department of Geography, Cooch College, to convey his welcome address. Thank you, sir, and over to you.
Am I visible and audible?
Yes, sir. Yes, sir.
Okay. Thank you, Priksha. Very good morning to all of you present today in this online special lecture series, both in Google video conference platform as well as those who are in YouTube live streaming. At the very beginning of this program, I must pronounce the name of our principal, sir, Dr. Pankaj Kumar Devnath, who always inspire us to conduct such venture in online in spite of the prevailing pandemic situation. He had told me yesterday night that he might be unable to join this program for an unavoidable circumstances, but had not forgot to convey us his best wishes for this program. It is a moment of extreme pleasure to welcome the guest speakers and the participants who are present here to attend this program. On behalf of the institution, as well as the PG Department of Geography, Cooch College, I offer my regards to both the invited speakers. Actually, it is a co-curricular part of postgraduate course in geography, 2nd and 4th semester, but some of our interested students of UG courses as well as the courses of certificate and diploma in geoinformatics have joined this program. I convey my gratitude to both resource persons of the day, Professor Ramkrishna Maiti and Professor Sujit Mondal. Professor Maiti is the Professor of Department of Geography, Vidyasagar University. Thank you so much, sir, for accepting our invitation and coming over and sparing your valuable time for the special lecture on need for environmental restoration and role of geographer. The schedule of the seminar will also focus on the topic of fluvial processes, bank erosion hazards, and livelihood vulnerability. It will include more issues to address the full aspect of the topic. It will be delivered by Professor Sujit Mondal, the professor and the head of the Department of Geography, as well as the Dean Faculty of Science, Diamond Harbour Women's University. I wish both the special lecture enlighten us all and provide us with approaches to deal with the problem of tomorrow. Thank you in advance, everyone who will make this session fruitful with their opinions, views, and interaction with the resource persons. I welcome you, all other academicians, the students, scholars, professors coming from the different parts of our country and joining this program. And also welcome our guest speaker. Thank you very much. Thank you all. Over to Priksha.
Thank you, sir, for your words. Now I would like to invite
Again, sound is very low.
Sir, now is it okay?
Yeah. Just hold it.
Okay. Thank you, sir. Now I would like to invite our respected faculty member, Debashish Talukdar, sir, to introduce our first speaker, Dr. Sujit Mondal, sir. Debashish, are you there?
Yes, Priksha.
Okay. Thank you. Over to you now.
Am I
Yes.
am I
Yes.
audible
It's
and
clear.
visible?
Yes.
Yeah. Thank you very much, Priksha. A very good morning to all of you present in this virtual platform. I am Devashish Talukdar, the faculty of PG Department of Geography, Cooch College. I feel highly privileged to introduce before you the great and wonderful speaker of national and international repute. Now, I am introducing the first speaker. Our first speaker is Dr. Sujit Mondal. He is the present professor, head of the Department of Geography, Harbour Women's University. He completed his degree the year 1999. Vidyasagar and Maiti. Karsyang towards water and that fusion. Did professor department of Jaja, he the department of Gourbango Faculty of Science. Well,
Devashish, you are not audible at all.
of this and foreign. Hello.
You are not audible and your internet bandwidth is not good.
Hello.
Yes. Try to finish your.
Am I audible now, sir?
Yes. Now audible.
Now audible. Start.
Apart from that, different institutions and universities had invited him for special lectures. He also supervised different UGC and ICSSR sponsored projects skillfully. Professor Mondal sir also has a host of national and international presentation and publications to his credits. He also published numerous articles and books from reputed national and international publishing houses. Beside it, more than 2 PhD and MP scholars already awarded under his supervision, and many more PhD and MPhil scholars still working under his guidance. The topic for his research, as for his speech, as you have seen, entitled as Fluvial Processes, Bank Erosion, Hazard and Livelihood Vulnerability. I hope this lecture will be more illuminating, enriching, and engaging lecture. Now, it is over to you, Professor Mondal sir. I cordially welcome you all. Thank you very much. Over to you, sir.
Thank you, Devashish. Am I audible to all of you?
Yes, sir.
Yes,
Perfectly
yes,
audible.
you are audible.
Absolutely
Okay.
audible.
Okay. First of all, I would like to congratulate principal of the Cooch Behar College and Dr. Tapun Kumar Das, coordinator PG Department of Geography, others faculty member of the PG Department of Geography, Cooch Behar College. Good morning to all of my students, research scholars, and teachers present over here. Let me present my topic. So I think it is visible to all of you. Okay. So I will speak on today online special lecture series, fluvial processes, bank erosion hazards, and human vulnerability. It's a great opportunity to me for being a part of online special lecture series organized by the PG Department of Geography. And once again, I congratulate PG Department of Geography, Cooch Behar College. So, fluvial geomorphology is one of the most important branch of the geomorphology, basically. And fluvial processes basically plays an important role for creation of the various relief features over the earth surface and evolutionary for making the changes or sequential changes of the landforms through the time. Earlier, civilizations, most of the civilizations actually established, which was basically based on the fluvial geomorphology, that is based on what I say running water and rivers. And in the present day, fluvial geomorphology basically incorporates various mathematical techniques and engineering geomorphology of the running water to explore what I say various parameters for the management of the rivers and for the management of the society. So fluvial geomorphology incorporates various processes, that is erosion process, transportation process, and deposition processes, and which actually generates various kinds of landforms and change the topographic expressions over the earth surface. And there is a close link between waters and sediments and catchment boundaries, which makes distinct features in a geographical environment, in a fluvial environment, and changes the bed forms, cross-sectional geometry, and platform geometry of an alluvial channels. The primary objectives of this branch of the geomorphology is to explain the relationship, physical properties of the flow, the mechanics of the sediment transport, and the alluvial channel forms. So we all know that the fluvial process incorporates three main types of processes, that is erosion process, transportation process, and deposition process. Erosion process is what I say dominated dominated in the upstream area. Middlemost section is dominated by what I say transportations, which is being accomplished by trunk stream, and deposition process is dominated what I say in the lowermost segment of a river basin. Basically, transportation plays an important role, and to what is the parameters competence and capacity, which where competence refers to the size of the particles that a river can move. That is actually very much related with velocity, and capacity, the amount of sediments a river can carry, which is related with the volume that can move, that can be moved by the river. These very two important parameters, very much important in case of running water and flowing water, and for changing the landform along the alluvial channels, and its riparian environment. And in fluvial processes, basically, it's a function of dynamic equilibrium, and equilibrium exists between what I say driving forces and resisting forces. Driving forces is being influenced by the gravitational forces, that is also related with slope and what I say the movement of running water, and resisting forces is very much related with rock types, topography, channel shape, vertical size of the channel. Whenever resisting forces actually exceeds the driving forces, sedimentation, siltation, formation of various types of channel forms and bed forms are being found. Basically, depositional features are being found as a result of the excess resisting force in comparison to driving force. Whenever driving force is greater than the resisting force, then erosional features and active erosional process, that may be what I say lateral erosions and vertical erosion may happen, and erosional features may be observed over the channel bed or in a basin environment. This is the idealized fluvial systems that has been propounded by the what is the SCOOM. And this very what is the concept is very much important in the analysis of the fluvial landscapes or what I say alluvial plains topographic expressions. Basically, uppermost segments is being treated as zone 1. That is actually characterized by number of drainage network and its continuous growth and development. That may be treated as the drainage basins, and where the erosions and erosions of the surface materials and productions of the what I say eroded materials and what is the production of the water is very much important. This is the zone of production of water and sediments from a river basins. And middlemost segment is regarded as the zone of transfer, or basically water and sediments actually accumulates and transport downward. Zone 3 is being regarded as the zone of depositions, where depositional features are very much dominant, and where distributed channels are being developed over the alluvial plains. And what I say, the fluvial systems can be divided into 3 main systems, that is collecting systems based on the system propounded by what I say SCOOM, another one transporting systems, that is the trans streams, whereas the dispersion systems basically dominate in the lower course of the what I say the river basins, that is of the mouth of a river. So this is the basic concept of a fluvial systems, and delivery systems divided into 3 important parts, that is collecting system, transporting systems, and dispersing systems. As a result of the changing of any kind of variables, erosional activities, what I say, velocity, discharge, and what I say, the slope angle, etc., changes of that very variables in a collecting systems or in a zone 1, that very changing character actually influences in the transporting systems and dispersing systems too. So changing of the variables in any kind of systems basically influence other systems, and all these systems actually closely linked with each other. Next one, so sediment regime and discharge regime of a fluvial systems, or what I say running water, are the 2 important aspects, and that very important aspect, sediment regime and discharge regime, basically influenced by geology, climate, vegetation, and soil, which makes actually the river more dynamic, and changing morphometric features are being found as a result of the what I say vegetation changes, climatic changes, soil character changes, and etc. According to some geomorphologists, there are some stressors, there are some factors which influence basins and channels. There are some external stressors or factors and internal stressors or factors which actually affect fluvial processes and fluvial morphology in a basin scale or at over a channel reach. So inside the watershed, urbanization process, construction of roads and other activities, storm drains, changes of the vegetation cover, forestry practices, use of groundwaters, basically altered hydrological conditions. And sediment budget inside the watershed is being influenced by the construction, forestry practices, water impoundment, that is construction of dams, mining, agricultural, vegetation changes. Altered topography is being accomplished in a watershed, basically occurrences of the landslides, volcanic eruptions, and any kind of what I say massive soil erosion processes and other kind of what I say constructional processes. Inside the watersheds or in a channel, hydrological attributes is being influenced by some stressors, that is construction of dams, water diversions, consumptive use of surface water. Sediment budget is being altered as a result of dredging, roads, and rail crossing across the river. Channel is being altered as a result of the channelization, dredging, bridges, bank stabilization structure, grazing, and removal or change in riparian vegetations, as well as by landslide occurrences or mass movement occurrences. So this is the basic factors or basic stressors inside the watershed, as well as inside the watershed at basin scale or channel scale, which are to be studied scientifically and systematically and rigorously to understand the fluvial processes operating in a geographical locations and to understand the various forms which are being developed and which actually influence other environmental problems, say for example bank erosion hazards, say for example flood situations, etc. So these very stressors today has become very much important for to study as a researchers, as a PhD students, for the management of the rivers or for the management of the riparian environment. Next, this is the one of the best example of the drainage systems. So we can divide our drainage basins into number of segments, and segment-wise analysis of the drainage network and its continuous growth and its development, changes in the number of streams and stream ordering, bifurcation ratio, etc., mean length of the streams, actually very much important. And sequential study of that very parameter at subwater scale basically gives an idea about the suitable locations where any kind of developmental structures may be incorporated. So all the subwatersheds are very much more dynamic as a result of the continuous growth and development of the drainage network, and that is to be studied very well, because all the individual watersheds contribute a certain amount of water and sediments, and which actually feed the main channels and make the main channels more dynamic and causes some of the problems that is closely related with bank erosions. So this is one of the most important pictures which can show you the changing character of the course of the river. No alluvial channels actually are straight enough. It is always changeable, because alluvial channels are subjected to a very common kind of processes, that is depositions. As a result of depositions of the sediments, cross-sectional area actually is being changed, and to adjust its cross-sectional area, river has to the course of the channel has to move sideward or downward, and has to maintain its earlier cross-sectional area and has to migrate laterally. And in this way, main course of the channel has to move one direction to another directions and takes the meandering loops. Let us have a look. Over alluvial channels, there is a sequential distributions of locations of other pools and refills. Over the straight course, there is a refills, and over the meander bench, there is a pools, and maximum depth has been found along the concave bank. And along the straight course, middlemost portions is there is a raised part that is being characterized by the river. So alternate sequence of the pools and refills are one of the most important phenomena over the alluvial channels, which makes the river much more dynamic. So fluvial processes of rivers are the result of interactions of stream flow, sediments, and river bed, and river bed controls the flow and sediment transport, which in turn enhance the change in the river bed. So sedimentations and creations of the chores and berths actually narrowed the river, and influence the main channel to flow through a narrow space, and as a result of which erosions, basically bank erosions, basically happens over the alluvial channels. So this is one of the most this very channel classification actually made by Scum in 1981, and he propounded channel types based on what I say load. He propounded 3 types of load. One is suspended load, mixed load, and bed load. Basically, state course of the river basically is being attributed by suspended load, and meandering course and braided course of the river actually dominated by the bed load. So in case of meandering channel, and state channels and braided channels, state channels having a low width depth ratio, and braided channels having a high width depth ratio. Whereas in case of gradient, state channels having low gradient and braided channels having high channel gradient. And if we consider what I say the bed load and total load ratio, braided channels having high bed load and total load ratio, and where the instability situation is very much common in case of what I say in case of braided channels and in case of alluvial channels. So these are the basic classifications of the channels that is being propounded by Scomes. Another channel characteristics, individual channel characteristics actually propounded by Smith and Putnam, and he revealed that percentage of silt clay over the banks basically moderate and low in case of meandering and braided channels. So the compactness behavior of the banks in case of meandering channels and braided channels become moderate to low if there is a moderate level and low level of silt and clay percentage, and bank erosions will be also moderate and low, because bank erosions actually happens over the bank stratigraphy having the percentage of high sand percentage and coarser particles. On the other hand, we can say lateral migrations. Lateral migration is quite common in case of meandering courses and braided courses because of the less percentage of silt clay materials along the river bank of the meandering and braided channels. So lateral migration is quite common in case of meandering courses and braided courses, which are being found in the alluvial channels over the Bay of Bengal. So this very picture is shown to all of you. This is the Gangetic river plains, and the river Ganges actually fed by number of tributaries, left bank tributaries and right bank tributaries, which contribute huge amount of sediments, and these very sediments are being deposited along the tectonic basins that is existing between peninsular shield and Himalayan mountains. And these very plains of the river Ganges actually forced the main trunk streams to move from leftward and rightward, and has made the river systems or channel systems is more dynamic. And as a result of this very dynamic character of the channels or main flow of the river has introduced several bank erosion problems, and that one of the most important or significant bank erosions is being found in Malla Diara regions, which is situated just above the Farakka barrage, upstream of the Farakka barrage, and between Rajmahal and Farakka, significant bank erosion problems actually is being found as a result of the channel dynamics, because upstream contribute huge amount of sediments, and as a result of the construction of the Farakka barrage, disruptions in the flow of sediments and water actually happened, and clogging of sediments actually took place between Rajmahal and Farakka, and as a result of which so many shorelands, stable shorelands, unstable shorelands, attached shorelands actually are being forming continuously, and eliminations of the shorelands are also occurring between Rajmahal and Farakka, and these very stretches has become much more dynamic as a result of the construction of the Farakka barrage. So let us have a look. The present this is the river stage between Farakka and Rajmahal, and let's see what are the situations of the stage between Farakka barrage and Rajmahal. There are number of shorelands which has been developed since from Farakka barrage to Rajmahal. If you look throughout the stages, several large what I say, large and stable shorelands actually are being formed, which actually force the main channel to flow through different segments, and alterations of the bars and changing of the shape of the bars and continuous creations and destructions of the shoreland over these sections has actually changed the flow velocity and flow directions of the channels, and has caused the lateral migrations of the main course of the channels leftward, and causing the bank erosion problems over the DRR regions, and causing the land loss, at basically agricultural land loss, settlement loss, vegetation loss is a quite common phenomena over these very states, basically Malda DRR regions. So let us have a look. What I say, the earlier situations of the what I say the flow of the river Ganga, there was no as such changing changing characters, changing nature of the course. That was more or less southward directions, more or less straight enough. And let's see, this very river course is flowing through distinct faults. One is Rajmahal fault, and another is Malla Kishanganj fault. And on the basis of this very geological phenomena, we can reveal that these very locations through which the river Ganga actually passing southward and southeastward through this Bengal basin are tectonically much more active, and tectonic tilting eastward actually also very much important for the creations of the leftward bank erosions and land loss. Not only that, basically rightmost part of the river, right hand part of the what I say Ganga rivers actually presenting the Rajmahal hills actually hard silt. So this actually resisting the rightward movement. On the other hand, alluvial tracts, that is DRR regions and marine regions, which are dominated by the alluvial soils, and towards that way, leftward, the bank erosions and shifting is quite common. So general tilting, general slope and tectonic activities, and existence of the what I say the alluvial tract leftward, basically much more responsible for shifting the leftward and causing the bank erosions problem in the DRR regions of Malda district. So several interrelated what I say features actually which are being found, that is the compaction of the fine sediments, tectonic movement which are common, and channel gradient eastward influences the channel migrations leftward in this very stage between Rajmahal and Farakka. So many geomorphic features very much significant, very found over the Bengal plains, that is extensive floodplains, sandbars, point bars, meander cutoff, oxbow lakes, wetlands, river island, meander skulls, etc. And let us try to know the Bengal basins of the Indian subcontinent, actually situated between Indian Silt and Indo-Burma range, and through which this very Bengal basins actually and main river actually is passing. Actually stable shelf, actually rightward, that is Rajmahal, central deep basins through which the what I say the river Ganga is passing, and Chittagong Tripura fold eastern part comprising the eastern part. So between Chittagong Tripura fold and what I say the stable silt of India, central deep basins, Bengal basin is located, through which the river Ganga is passing, and continuous as a result of the deposition of sediments, what I say the large alluvial tract has been formed, and through which a constricted channel or flow path of water is passing and causing the river much more what I say dynamic. Let us have a look. So many bank erosion features over this very stage. Have a look. Formation of linear cracks and failure as a result of the scouring process. This is the what I say one of my students actually measuring the bank height. Bank stratigraphy is very much composed to loose sand. Let us have a look. Uppermost part is the what is the finer particles, where compactness is very high, immediate lower to stratigraphy is dominated by what I say the very sand, very fine, very coarse materials, which are very loose in character. And there are some number of students actually measuring the some number of hydrological features of topography, and this is the newly developed shoreland. And where we visited, this is the newly developed shoreland, and there are so many shorelands which are going to be developed over the river bed. There are so many submerged shorelands over the river bed Ganga. Let us have a look at the destructions, and these destructions actually caused as a result of the opening of the what I say sluice gate leftward of the Farakka dams, Farakka barrage. And as a result of the opening of the sluice gate, flow velocity increased. Flow velocity increased as a result of the increase in flow velocity. Hydraulic actions caused these very destructions over the left bank, just immediate upstream of the Farakka barrage. There are some another destructions. The people are moving from one place to another places. This is the severe destructions caused due to bank erosion process. This is another severe destructions caused due to bank erosion processes. So according to Knighton, the river bank stability and instability basically depends upon storm frequency, flow properties, variability of stream discharge, bank materials compositions, bank geometry, bank moistures, soil moistures, channel geometry, vegetation type, man-induced factors. So scientific knowledge on these very bank erosion factors are very much essential for planning of the flood-prone area, bank erosion-prone alluvial tract of the Bengal basins. And this very two pictures are showing the development of the what I say channel bar or mid-channel bar, and changes in the flow directions of the channels. And these very changes in the flow directions, sudden changes in the flow directions as a result of the depositions and formation of the shoreland over the river bed makes the what I say surrounding land more vulnerable and create the bank erosion, causes the bank erosions problems. So first one, I am going to show you the several bank erosion processes. First of all, the running waters or erosive power of the stream. First of all, erosions erode the toe slope, and as a result of the hanging part actually collapse and bank erosion happens, and recession of the bank slope causes. And in the study area, left bank of the river, left bank of the Ganga river, between the states, actually there are three important stratigraphy. Upper part is more or less stable. Compactness of sediment is quite common. Immediate lower part is non-cohesive layer, and below stratigraphy is characterized by cohesive layer. And from that very non-cohesive layer, continuous piping of the materials actually happens. And this very piping of the materials actually weaken the upper surface and create what I say numerous cracks. And finally, block failure, block of marks and block of what are the soils actually happens, and that leads to the bank erosion processes. Another third one is the scouring process. This is one of the most important factors of bank erosions as a result of the changes in the direction of the flow velocity. Toe slope actually is being scoured, and this very processes actually leads to bank erosion processes, and recession of the bank actually happens. So bank erosion processes is one of the most important processes which changes the channel courses, and to assess the changing character of the river course between Rajmahal and what I say the Farakka satellite image actually is are being taken into account, and geospatial technology used to explore the changing course of the river since 1955 to 2015. This is the what I say character of the river, nature of the river, 1967, 85, 1955, 1973, 1979, 1996, 2008, and 2009. So let us have a look. Continuous changing character of the flow path of the running water or river, and continuous changes of the what I say the state shorelands, which are very much common throughout the states between Rajmahal and what I say along this very stage. Continuous changes of the what I say the river bed sedimentations and its forms. Shorelands are much more dynamic and continuous changes its shapes and area are very much common, which has made the tract very much vulnerable caused due to bank erosion processes and channel migration processes. This is the course. This is the shifting character showing since 1955 to 1973, and which reveals that lowermost segment, middle to lowermost segment has been changed significantly. Another one, silver course showing since 1973 to 1979, no significant change has been found. Next one, I am going through the river course of 1979 to and 1996. This is showing the significant changes in the lower part. Then 1976, 1999. This is also showing the some dramatic changes of the river beds. Actually, middlemost portion is very much significant in terms of changing behavior, and leftward side is changing frequently through time. This is the river course of the 1999, 2008. This is 2008 and 2015. So it will go for analyzing shifting behavior. Shifting behavior since 1972, so 2015, we can observe the uppermost part and middlemost part and lowermost part. Basically, the river bank has been shifted leftward, and basically in the middlemost sections, channel width has been changed significantly. The variation of the channel width is much more significant in the middlemost sections. The study of the river course since 1972 to 2005 reveals it. So, as a result of the analyzing changing course of the river Ganga through satellite image and GIS software, it is being stated that Manikchak block is very much affected by land loss. Then Kaliachak 3 and then Kaliachak 2. So Manikchak area is very much affected by bank erosion processes and channel migration processes. This is one of the best examples. The development of the shorelands and instability of the shorelands. Let us have a look. This is the one of the a small part which is situated here is the Farakka Barrage, just immediate upstream of the Farakka Barrage. There are some moujas, and this is the water bodies. A small shoreland actually is being developed in 1991. Then let us have a look. In 2001, a big shoreland actually is being found. The position has also been changed. Let us have a look over the 2011. The aerial extent actually is being reduced, and position of the shoreland has also been changed. Let us have a look. 2016, the position and area of the shoreland has also been changed. So continuous changes of the shoreland and water area and flow directions of the main channels are very much common phenomena, which is caused as a result of the deposition of the sediments, large-scale deposition of the sediments, and construction of the Farakka Barrage. Eco-soundness survey has been accomplished over the riverbed of Ganga to assess the channel bathymetry, bed form, also the depth character, as well as the the position of the channel thole. So this is the Fula river, which is actually meeting the main river of the river Ganga, and this very Fula river also contributing huge amount of sediments, and these very places has become much more dynamic. All these are the profiles that actually are being studied. So this is the AB island. This is the position of the Tholoic CD along the at the places of the confluence of the Fula river. This is the EF at the confluence, where we can see the deposition over the river beds, and over the Tholoic positions is very much close to the Bhutni Chor. This is the Bhutni Chor, at one of the most stable chor, which actually flows to the river Ganga, to flow actually southward. This very raised part actually showing the deposition of the sediments, and these very depositions may raised in future. Let us have a look. These very cross sections actually showing there are number of ups and downs, and these very ups and downs actually showing the deposition of sediments and its removal of the sediments through time. And deepest part is situated close to the Manikchak. Another one, 3.1 kilometer north from Manikchak Ghat. This also showing a number of depositional features of the riverbed or uneven distributions of the depth, which showing the depositions, large scale depositions and its deposition of sediments and its movement through time. This is another 2.4 kilometers from the downward from the Manikchak Ghat. These are also showing the development of the channel Tholoek in the middlemost sections, and its surrounding sections is dominated by the depositions. And always the changing behavior of such very depositions and erosions and changing of the Tholoek is actually reveals the adjustment of the river flow, adjustment of the the cross-sectional area. River actually tries to maintain its cross-sectional area and also the flow area, and as a result of which it actually removes its sediments and sometimes changes the position of the Tholoek. This is another sections. Another sections very much close to 1.6 kilometer from the Manikchak Ghat. This is 1.01 kilometer from the Manikchak Ghat, and this one actually lower part of the Manikchak Ghat, showing the deepest part very close to the Manikchak Ghat. This one are also showing the deepest part where the velocity, which shows the velocity, maximum velocity close to the mainland. This very picture also showing the maximum velocity very close to the mainland. This is also another three sections, cross profiles. Let us have a look these very sections. This actually covering where the width of the river actually maximum large number of raised part depositional features actually is being found over the river bed, and number of depths, number of deepest part are also being found over the river bed. So continuous dissections of the submerged shoreland and its development actually quite common, and these very places may also be exposed to the surface, water surface, and may be a stable shoreland may be formed. This picture also showing the same features. A stable shoreland may also be formed, and this is the submerged shoreland. And this very development of the submerged shoreland actually changes the flow velocity and flow directions of the along the cross sections of a river, and makes the channels more dynamic and creates channel migrations. This is the bathymetric map based on the depth of the river through this stage. A bathymetric map has been developed, which shows the low depth. The red one is showing the low depth, and very close to the north of the Manikchak and south of the Manikchak, very close to the river, the maximum depth is prevalent. And river has to pass through the narrow space where the flow velocity is maximum and bank erosion is becoming quite common. In the northern part of the Manikchak Ghat, and left-hand part very close to the Manikchak, northern part of the Manikchak, where the depth is maximum, and the opposite side where the depth is minimum. And as a result of which, maximum water has to pass through this narrow channel along the riverbank, very close to the riverbank, which causes the riverbank erosions. So a platform study actually is being made to assess the intensity of the breeding of the rivers. And after Sharma et al. And the platform index actually estimated along the 30 cross sections throughout the stages since Rajmahal to since Bhutnichor to Bharat coverage, and which shows the different kind of variations in the platform index, just actually calculated after Sharma et al., which actually considered flow top width and overall channel width and number of braided channels. And this is the cross sections for the 1975, 1995, and 2015. So we considered actually, that has been considered. And reach-wise, if you go through the platform index, we can find what I say the uppermost segment having what I say the lower platform index, and in the middlemost stages and the lowermost stages having high platform index, which actually reveals what is the number of shorelands, number of what I say the breeding, number of segmentation of the streams, not segmentation of the channels. And if you imagine the changing course of the river Ganga, which is very much pronounced, is very much pronounced to the middlemost segment and lowermost segment of the very stages. If you think the channel width and variation of the channel width, which is very much pronounced in the middlemost segment as well as the lowermost segment. So platform index is very much high in the middlemost segment as well as the lowermost segment, which actually showing the breeding intensity is very high, as well as the channel width, variation of the channel width, and variation of the segmentation of the channels is quite common in the middlemost segment and lowermost segment of that very stage, that is between Rajmahal and Farakka in comparison to upper part of that very segment. So riverbank stability study actually assessed by estimating the bank erosion hazard index as well as the near bank stress. To estimate the bank erosion hazard index, all these parameters actually are being taken into account, and to assess the near bank stress, near bank maximum depth and bank depth actually may being considered, and bank erosion category, bank erosion status or riverbank stability character actually were assessed. In the Manikchak block, most of the sites, 15 sites are being taken into account. 5 for each blocks, Manikchak, Kaliachak 2, Kaliachak 3. At Manikchak area, all the sites are under what I say high to very high Behi index category, and showing the bank stratigraphy of bank very much unstable in character. In case of Manikchak regions, if you consider the what I say the near bank stage is also very high in case of Manikchak area. The sites located in Manikchak block, and as well as the Kaliachak 2 block, where some cases the very high and moderate level of what is the near bank stage actually is being quite common. This actually revealing the erosion status or channel migration status of the left bank of the river Ganga. This is the sites of the left bank, and number of what I say number of sites was 15, and the red one is showing high, very high bank erosion hazard index. Yellow portion is yellow point is showing the what is the high bank erosion hazard index, and this very picture is also showing the same very high depicted by the red one, which is common in the Kaliachak, which is common in the very much common in the Kaliachak area. So, considering the changing character of the river course and considering the bank erosion hazard index and amount of land loss for the year 1995 and 2016 actually are being taken into account. Okay, so analysis has been made amount of land loss since 1995 to 2016 land loss, and there are some positive changes, creation of shoreland, positive changes, and destruction of the land. Negative changes actually took place at several moujas located along the river bank. And considering the land loss in 3 blocks, a bank erosion vulnerable zonation map actually was being prepared. Some moujas actually Kharibhat, Jhaubona, Rejapukur, Kamaluddinpur, Doriadiyar, Jhaubona actually very much affected by what I say erosion to narrow, where land erosion actually is quite common. Maximum land has been lost as a result of the what I say the bank erosions. So middlemost portion is very much affected by the affected by the bank erosion problems. So a land use land cover change study has also been made we considered for the images, satellite images for the year 1973 and 2015. The study revealed that the conversion of the agricultural land, conversion of the seasonal agricultural land and settlement land to the water bodies and to the barren land, and to some extent vegetation and scatter type of the forest and vegetation is quite common. Not only that, sometimes water bodies is being transformed into what I say is settlement agricultural land, seasonal agricultural land, etc., etc. Because some stable shorelands are being formed over the riverbed, and this very stable shoreland is being used for agricultural practices. So, settlement area, vegetation area, seasonal agricultural lands, agricultural land, fallow land, mostly converts to the water bodies in the study area, and sometimes water bodies is being converted into seasonal agricultural land and vegetation is covered in the study area. So this very stages also showing the land use diversity which is being caused as a result of the what I say the river bank erosions. Not only that, people sometimes move from these very places to other places, safer places, and the reduction of the settlement area is also becoming quite common in this very studied area. So the bank erosions has what I say some destructive impacts in the study area, which influences socially, economically, and there are some other impacts. Socially, homelessness, migration, identity crisis, major or important issues. Economically, loss of productivity of the agricultural land, loss of occupations, income erosions, and loss of what I say livelihood status and the risk of poverty. These very bank erosion problems, land erosion, agricultural land actually invite poverty situations, because most of the rural people in this study area basically depends upon the agricultural land, and that's very agricultural land as we destroyed year by year, every year a lot. And the income of this very rural people and occupation of the marginal farmer or what I say daily wages laborer actually is being hampered as a result of the such destruction of the agricultural land. So not only loss of productivity, creation of the poverty and loss of income, basically large scale income erosion of that very region is quite common, which has introduced several other problems, that is improper care of for health, lack of education attainment, children does not go properly to could not attend their schooling properly due to lack of income of the family, and as a result of which poor people actually are being forced to adopt criminal activities. So social crimes and other kind of crimes is very much common, which is caused as a result of this kind of environmental problems. So right now, government is trying to take so many positive steps, providing what I say some facilities to the common people to reduce these very problems. So to assess the livelihood vulnerability, 50 mojas, 20 mojas from Manikchak, 20 mojas from Kaliachak, and 10 mojas from Kaliachak 3 actually were being taken into account to assess the livelihood vulnerability index. Okay, and 500 number of households are being considered, and data were being collected through well-structured questionnaires. And first of all, livelihood vulnerability index value actually are being taken into account. And to calculate LVI, 7 major components and 48 sub components are being taken into account. 7 major components are socioeconomic profiles, livelihood strategies, social safety, health, food, water, and natural disasters. And there are 48 sub components which are also under what I say 7 major components. And to assess the LVI, first of all, we standardize sub-components of an area, then average value of each major components of each point actually being calculated. And after that, each major component of average value is being multiplied by 48 major component, 48 sub-components, and that was divided by for individual what I say major components, such as health, food, etc. And finally, LVI actually estimated, and this very value ranges from 0 to 1, and 0 indicates less vulnerable conditions, and 1 indicates the extreme vulnerability situations. And P1, P2, P3, P4, P5, P6, it's actually revealing the name of the mojas, location of the mojas, and these very components, 7 major components, and this is the final LVI scores. In Manichat block, 12 mojas are falling under the moderate to high livelihood vulnerability, and basically, maximum mojas are under threatened conditions. Economic conditions are very poor, and the care should be taken from taken for improving health, income, food, water supply, and social safety. Next one, in case of Kaliachak 2, 7 mojas are under high livelihood vulnerability, and 10 mojas are under moderate, and 3 mojas are under low livelihood vulnerability. In Kaliachak 3 mojas are attributed with high LVI, livelihood vulnerability, 5 mojas are moderate, and 2 are under low LVI. It has been observed that mojas located very close to the river are registered with high livelihood vulnerability because of the bank recession, channel migrations, land loss, etc. Quite common, very close to the river bank. So the river Ganga is passing through the. I am trying to sum up the whole things. The river Ganga is passing through the tectonically active alluvial plains, and whereas general tilting of the region is quite common, and it is towards southeast, and general slope is towards southeast. So the tendency of the movement of the river leftward is quite common, and it is one of the major causes for the occurrences of the channel migrations and bank erosions leftward. Not only that, what is the prevalence of the alluvial tract, which is very much erosion prone, which is being aggravated due to the flow velocity and flow direction changes. Both upstream as well as downstream are severely affected as a result of the construction of the Farakka barrage. Actually, we have already observed formation of the chores and its modifications of hydrology. Geomorphology is common phenomena which causing bank erosion and making the river more dynamic. Destruction of the agricultural land, settlement, human life, and properties will happen near futures, and we cannot resist it. Okay, we have to think in different way for solving the problems. What should be done? Okay, to minimize the damage caused by the lateral shifting and river bank erosions, human intervention in the whole river catchment and along the river bank must be avoided. We should not interrupt the flow of river. We should not interrupt. We should not move for any kind of engineering constructions without considering geomorphological parameters or basically fluvial geomorphological knowledge. And planners, policymakers, and engineers must follow the ideas from the geomorphologist and fluvial geomorphologist with regard to river character, channel character, so that the damages caused by fluvial erosion problems, bank erosion hazards, flood hazards of any riverine environment or floodplain environment can be minimized. So thank you so much.
Thank you very much, sir. So, Priksha, are you there?
Yes, sir.
Okay, please proceed.
Okay, sir. Thank you very much, sir. Sir, am I audible?
Yes, you're audible.
Okay. Thank you very much, sir. Now we will continue with the question answer session. And for that, I would like to invite our respected faculty member, Shonil Shaw, ma'am. Professor Shonil Shaw, ma'am, over to you now.
Thank you, Priksha. Thank you, sir, for this nice and very systematic and very lucid presentation. Also with your nice elaborate explanation too. But still there is no question in the chat box from the audience side. Is there anything in the YouTube streaming? We can't see. So if any participant want to interact with him and want to discuss anything with sir, they can raise their hands. they can raise their hands, and we will surely help them to interact with him. Is there any participant who want to interact with him? Is there any query from their side? They want to know little bit from. Yes, who is this? Oh, Vijit, yes.
একটু পরিষ্কার করে বলো যে একটু বলো। হ্যাঁ হ্যাঁ some mojas are not being actually affected by erosions as well as not affected by depositions, and there is no as such actually changes actually happened. Okay, most of the mojas actually affected, but some mojas are not being affected by erosion as well as depositions, and that remains same between 1995 and 2016. Okay.
Okay. Is there any participant who want to interact with him?
Devashish Talukdar has
Yes,
raised his hand.
Devashish, please.
Hello. Hello.
Devashish, please continue.
Am I audible, madam?
Yeah, you are audible.
Sir, actually, I have a question to you, sir. Actually, as you have mentioned that as per after Kington, 1998, that the factors influencing the bank erosion, as you have mentioned, like storm frequency, then flow properties, variability of stream discharge, bank geometry, and all these. And lastly, you have mentioned the man-induced factors. My question is to you, sir, from your point of view, how sand mining impacting the bank erosion?
Please repeat, please, Devashish.
Sir, am I audible now, sir?
Please repeat.
Repeat, okay. Sir, as you have mentioned, as you have mentioned in a
Yes, I
slide.
have mentioned so many factors.
Yeah, so many
established
factors.
by
But
Knighton.
lastly, you have mentioned the man-induced factors. But my question is to
Yes.
you that how sand mining impacting the bank erosion from your point of view, sir?
No. This is the general understanding that was propounded by, that was given by Knighton. Okay, and sand mining
Yes,
also, sand mining is not taking place in that very study area. That is the general understanding for causing the river bank stability. Some rivers over the Bengal, Kamshaboti, Ajoy, Damodar, as a result of the sand mining dynamicity actually is being caused. Okay, but in case of this our study area, engineering construction, that is Farakka barrage, clogging of sediments, and some kind of the activities operating along the river bank, agricultural activities, what I say, navigation route actually is being established along the Mahicha Ghat, which putting enormous pressure over that very ghat. Okay, that actually causing bank erosion problems.
Oh, yeah, sir. Thank you, sir, for your proper guidance.
Okay. So, is there any other participant?
Hello, sir. I am Kanai Paul.
Yes.
Hello, madam. I am Kanai Paul. I have a question to sir.
Okay.
What are the innovative measures of river bank erosion? That means how we protect the erosion of a river. Hello, sir. Am I audible?
Yes, yes, you are audible. I have got your point. Okay. So
Yes, sir.
channel migrations actually over the alluvial floodplains, it is quite common. Okay.
Yes,
So
sir.
we cannot resist the channel migration process completely.
Yes,
So
sir.
strong initiatives has to be taken. Real understanding of the geomorphological knowledge to be assimilated, to be taken into account for what I say, any kind of engineering constructions along the river bank, and considering the morphodynamic variables, morphodynamic parameters. We cannot totally stop the river bank erosion processes because every streams or channels actually have to maintain. Actually, I have told you that it's called cross-sectional area. We cannot resist the total depositions over the river bed. If deposition happens, then it will start to migrate to other area. So completely we cannot, we can manage dredging the river, dredging the channel beds, and each actually requires, it actually needs, it is very much costly. Continuous dredging process and maintaining its flow path and channelizations really, it is to be done properly. And it is not done properly throughout the river course, and that's why the channel migrations, these very situations will also be happening, and this is quite impossible. So many shorelands actually is being found, stable shoreland has been found, and if you go for dredging, so we can think what situations may happen in this very study there. How much amount is to be invested to clear out the sediments over there. Otherwise, these very situations, along this stage actually will happen. If you go to the upper stage beyond Rajmahal, so Bihar state, sometimes Nitish Kumar is saying that what I say, Farakka Barrage is causing the main problem. It resisting the flow of the river Ganga and causing the flood situations and bank erosion problems in the upper stream. So the restriction and construction of the this very situation in engineering structure should be taken into account very scientifically, and proper knowledge, proper understanding is very much required.
Thank you, sir. Thank you.
Okay, thank you, sir. And thank you all the participants for interacting with him. As actually everything of this river actually is mainly dependent on prevention and our understanding also. Nothing can be stopped because it's a natural process. So we have to allow them to carry on. By the way, we are ending this session here, and our next speaker is has also joined us, and I now convey to Priksha to continue the next session. Thank you all, and Priksha, over to you
Thank you
now.
so much. Once again, I extend my hearty thanks to all the faculty members, Department of Geography, PG Department of Geography, Cooch Behar College. Especially, I also thank to Dr. Das, Dr. Tapon Kumar Das, convener of this online special lecture series. Thank you so much. Thank you, Devyu.
Thank you. Okay.
Thank you, sir. Thank you.
Thank you, sir.
Diksha, please continue.
Thank you, sir. Thank you very much for your valuable words. Now I'm going to welcome our second speaker of today's lecture session, and I'm very much glad and honored to introduce such a personality. Dr. Ramkrishna Maiti, sir, is the professor and head of the Department of Geography, Vidyasagar University. He has completed his master's degree from Calcutta University in the year 1997. And after that, he was awarded for his PhD degree from Calcutta University in the year 2004, entitled Mining and Environment, a few case studies from Eastern Himalaya. He has been serving in several institutions like Kashin College, Darjeeling Government College, Vidyasagar University as a teaching faculty since 2001. Apart from that, he has presented papers in numerous national and international seminars and conferences. He also published number of articles in reputed journals. Professor Maiti was invited from various national and international institutions for special lectures. His area of specialization are mining, environment, slope instability, flood impacts, and many more. And we are also proud to announce that Professor Maiti has ensured his remarkable position among the 3 highest ranked Indian geographers assessed by Asia Scientist and University Ranking 2021. Till now, he has been supervising 24 research scholars, out of which 11 scholars are already been awarded with the PhD degree. 5 scholars have submitted their theses under his supervision, and 8 scholars are still pursuing the degree under his guidance. He also successfully completed several projects under his supervision. Professor Maiti published number of books from reputed publishing houses, among which we all, the students of geography and teachers, all we know the Adhunik Bhumirup began from him. Thank you, sir. Thank you for being with us. Now the session is all yours. Thank you, sir. Professor Maiti, sir, are we having you?
Yeah, please. Am I audible?
Yes, sir. Yes, sir. Thank you, sir.
Thank you, Priksha, for your nice introduction. And at the outset, I like to thank Dr. Topon. He's my friend, and I like to thank him because he requested me to deliver this lecture. And I must be thankful to college authority also for inviting me, for formally inviting me to deliver this lecture, and other faculties of geography, Cooch Behar College. And thanks to my say colleague come friend, my student also, Sujit, for delivering a fantastic lecture. Although I was not able to be present, say, for the entire session of lecture by him. With this, I like to start my deliberation today. Let me share my presentation. My slide is visible?
Yes, sir.
Okay. So today I like to draw your attention to a contemporary and very important topic of ecosystem restoration initiatives. Actually, this year, United Nations has declared the entire decade from 2021 to 2030, this decade as the decade for ecosystem restoration. Now it is our time to introspect what is our ability and what best we the geographers can do, and how we can participate in this program, global program, national program, as well as the local programs. And let me draw some introductions about the necessities of ecosystem restorations and how we are coming to this place where ecosystem restoration is necessary. So I have organized my lecture today in this way. At first, I like to draw your attention to the earlier ideas about the environment, about the ecosystem, and how we are changing our attitude towards the nature over the time, and then what are the methods, prescribed methods for ecosystem restoration, what are their stages. And I like to stress upon a single method of removal of impacts. What impacts we have on the ecosystem, on the environment, if those are removed, if those human impacts are removed from the environment, then what would be the situation? And it is expected that ecosystem will be revived. And I will give the special emphasis on river restorations. How we can remove the large dams, and how we can remove the check dams, remove the bridges or embankments, which are the important structural measures, and what would be the impact if we remove all the large dams, check dams, bridges or embankments suddenly. Okay, what should be the precautions and what would be the role of the geographers? So this is how I like to organize my lecture today. And already I have told you that this is the decade for United Nations decade for ecosystem restoration. Okay, now the idea of ecosystem restoration, or idea of our sympathy towards the nature, was first drawn by George Perkin Mars. And he wrote a book in 1864, Man and Nature, where he cautioned us that the way human beings are deforesting, clearing the forest, will lead to a kind of desertification that we are having, that we see, the surface that we see on the moon. Earth's surface will be transferred to the surface of the moon if we carry on the pace of deforestation that we had during that time in the Mediterranean region. That time, near the Mediterranean region, huge rate of deforestation, the first rate of deforestation occurred, and he made us cautious about that deforestations, and then he advised us to stop that range of deforestation. You know, human civilizations, this is the phase of human civilization, not only in Europe, in America also after the recovery, after the discovery of America, huge land was deforested, cleared for the habitations. And after that, in 1948, there was an international body, International Union for the Conservation of Nature, IUCN. You know the activities of IUCN. They are trying to preserve the world species, and they are making survey of the species, plant species and animal species, and they found that there is a need for protection of environment. And it is for the first time in 1948 one international platform or forum was established to make this demand or make this idea popular among the world bodies. And you must know the book wrote in 1949 by Aldo Leopold. The name of the book was The Sand County Almanac. Aldo Leopold was a ranger, and he was appointed in New Mexico for hunting the wild animals which are disturbing the civilized society. And while hunting the predators, he found that those predators are important in the nature. As what we found today, that the presence of tigers are very important in Sundarban. So he felt for the first time in 1949, and he has proposed a very important philosophy of environment, the ecological ethics, the land ethics, where he said that man is a member of the world community, like other species. man should not predominate, man should not dominate the world ecosystem, but they should be only the member of the systems. And they have to harness the resources out of the environment. They should not predominate, they should not conquer. They should not conquer. Okay? They should not be the conqueror of the land community, but they should be the plain member and citizen of the community. Okay? That means if we follow this principle, it would be say everywhere the natural ecosystem preserved. We shouldn't disturb the natural ecosystem. So first idea of the environmental restoration, ecosystem restoration, or ecological restoration came from this idea of ecological ethics. And wherever we go, we have to follow our Tagore, Rabindranath Tagore. We are proud of him. In Muktodhara, in 1922, he wrote a debate between the lower catchment and upper catchment of a large dam. Okay, what should be the debate and what should be the outcome? What would be the outcome if a river is closed by the large dams? So in Muktodhara play, you can see elaborate discussions about it. And when he was writing it, that time the Western world is trying to build the large dams. So in 1922, the Mississippi Corporation was established. Okay, Tennessee Valley Corporation was established. So when the Western world couldn't realize the impact of large dam, Rabindranath Tagore realized it. And Shabhotar Prati in Choitali, he wrote, Dao Fireshe Oronno Lohoye Nogor. Lao Joto Loho Lostro Kasto Prostor, He Nopo Shabhota. The citizen, the civilization, new civilization, he was not happy with the new civilizations. But he proposed for the revival of the forest. And he asked, Kano mure gelo nodi? Ami bandh banditare, chahi dhuribare, paibare nirobati. We want the river to hold water throughout the season. That's why we constructed the dam. And that's why the river had died. There is no flow. It's a dead river. It's a dead river. If you ask the primary children, what flows through the river? What is there in the river? They will ask you, they will answer only sand. Because throughout the year, they find the sand in the river. Because we transfer the river from a flowing water to the flowing sand. Okay. Now, our attitude towards nature is also being changed over time. And if we look at the age of the Purans, you see the great event of Khandab Dahan in Mahabharata. You see, Indraprastha was constructed after the burning of a large forest like Khandab. And during this burning of forest, there was also the conflict between the gods. Agni tried to burn it, but Indra and others, they tried to stop it. And Lord Krishna and Arjuna, they took the side of the Agni, and ultimately he was successful to burn the forest. And as a return, Agni gave Arjuna the Gandit, the bow, and Lord Krishna the famous Sudarshan Chakra. And you know, these are two important arms they used during their fight over Kurukshetra. If they don't have these two arms, the situation may be changed. So during that time, and since that, we accepted burning of forest. burning of forest, there is no harm in burning of the forest. It is accepted. Okay. But the time is changed. When we found the limits to growth in 1972, that there we found nature has the limit. We couldn't cross the limit. We couldn't say cross the limit of our impact. We couldn't cross the limit of our distractions. During wastewater management, what we did earlier, all the wastes were directly thrown into the river, and we followed the principle of dilutions. All of the municipalities, older municipalities and older civilizations, industrial sites, industrial complexes, all were situated either near the river, bank of the river, or near the ocean, where the facility for wastewater discharge was taken first and foremost. So they directly sent discharge their water into the river. But presently what we found, that no, the nature has the limit. If we keep on going like this, the nature will be polluted, total environment will be polluted. And so we are concentrating the pollutants out of the polluted water, wastewater, and then we are releasing the fresh water into the larger system. So our approach has been changed from the dilution to the concentrations. And if you look at the urban centers, side by side of forest, forests were told as jungles. If we utter this word jungle, we are using this word jungles in everyday life. Jungle means it's a discredited one. It's a chaos. There is no order. It is a chaos and it is a disturbance. But presently, we believe that a jungle, a forest, has the ecological order, and it is the meaning of freedom. And previously, we found the city as the symbol of order and glory. And during the modern age, modernizations, urbanization was considered as one of the important criteria for modernization, because it was the symbol of glory and symbol of order. But presently what we found, city is a jungle of concretes. So the attitude and our way of understanding, way of thinking changes over the times. Now in this background, we came to the phase of ecological restorations. How we can restore the ecology? There is a continuum. There is a continuum of process. At first, we have to reduce our impact. Then we have to try to improve the ecosystem management. We have to manage the ecosystem. Then we have to try to repair ecosystems by planting the trees and introducing the native vegetations. We have to take more initiatives in the recovery of the native vegetations, partial recovery phase and full recovery phase. And these two phases are reducing impact phase. These two phases are the phases of remediations. These two phases are the phases of rehabilitations. And these three phases are the phases of ecological restoration. Until and unless we come to this phase entire restorations was not possible. Okay. Now, how we can remove our impacts? See, this is an example from the Merit River of Italy, and you see series of check dams which were constructed for the restoration of water harvesting, and afterwards these has been removed. Very recently, these have been removed, and then you see the river has recovered its partially recovered its original shape, but still there are the impressions of the dams somewhere. Improving ecosystem in lowest plateau of China. You know, the China is facing the problem of desertifications, and they took this initiative long ago, 10 to 15 years ago, and it is a part of the lowest plateau, and it was like a desert, and now you see it is being transferred into a good ecosystem, at least partially recovered ecosystem, and they are following the principles of remediations. Now again, anti-desertification drive in China, in Inner Mongolia. These are some of the areas. It's a mining site. In Inner Mongolia, they are trying to introduce the grasses, and they are favoring the grass and other vegetations to grow. And these are the anti-desertification drive they are following. Now, repairing of ecosystem. They are trying to repair ecosystem. It's an example from West Sussex. And there was a huge land which was intensively cultivated before. But gradually the return or the productivity of the land is reduced drastically. And so now they are turning this land into the natural ecosystem. And at first, they are introducing the native wild animals. Okay? And those animals are bringing seeds and dropping those animals and birds. They not only animals, they are also birds. From the bird droppings, the native plants are grown hugely. And so this is how they are trying to repair that ecosystem, which is lost earlier. A creek project, Atacadero Creek project of California. And here they planted nearly 2,800 native plant species since 2011, and within 10 years, this area has been partially recovered. And in India, one abundant limestone mining owned by Shell, Steel Authority of India, as Purnapani in Odisha was left like this. It was a deserted area, and their ecological restoration drive has been taken, and you see what is the growth of the vegetations, and all these are the native vegetations. So it's a moderately recovered ecosystem, and any of the process we can follow. Now, as I told earlier, I will put stress on river restoration, and I will inspect what are the methods and whether withdrawal of the impacts are judicial or not, removal of large dams, check dams, and embankments. And here the organizing concept says this, that these are the disturbances. Sometimes disturbances are low, sometimes disturbances are high. If there is high disturbance, the system will change, and system will try to recover afterwards. But if the change is very high, then the system will not recover, cannot recover. It is the early recovery, rapid recovery system. It is the delayed recovery system. But in this case, there is no recovery. And if you totally stop the flow of a river by large dam, in most cases, river has shifted its threshold, and it has come to a new recovery stage. And if you remove the dam, river cannot come back to its earlier positions. So the changes that we did, is the irrecoverable changes. Let's have a look. These are the large dams on Krishna River, Sri Shoilam Dam. Okay, you see how the total river has been closed. It's a dam across the river Nile in Ethiopia. Numbers of dams are there in Ethiopia. And what happens if a dam is constructed in between the source and mouth? It is the source and it is the mouth. Then earlier it was the base level. Now the base level of the river is shifted. If the base level is shifted, the length of the effective river is reduced. And as the horizontal distance or length of the river is reduced, the gradient will be sufficiently high now. And the graded condition, it was the graded condition earlier, and that graded condition was established for past millions of years. And just now, after constructing the dam, you disturbed this graded condition, and river has to cut its valley further to get this graded condition. That means after construction of the dam, in the upper catchment, more erosion is obvious results. You need not to do anything, but river will cut its valley, river will erode more and more to get its equilibrium. And this happened. And in most of the cases, huge sedimentation occurred behind the dams. And you see, over thousands of large dams are there in India. It is a United Nations report. There are thousands of large dams in India which crosses which are old, which will be older than 50 years in 2025. And most of the people of the earth are living downstream of 10,000 of such old dams. Now, the time has come when you have to remove these dams because water holding capacity has been reduced and those dams are older now. If those dams are removed, then most of the people of the world are to face the hazards. And there are 58,700 large dams, and which will cross 50 to 100 years of their lifespan recently. Between 1932, they were constructed between 1932 and 1970. So this is one of the greatest challenge to human civilization, and where a geomorphologist, a river geographer, or a simple geographer has to play their role. And you know, in America, hundreds of dams have already been removed. Here, 131 dams from this state, 207 dams, 75 dams have been removed. So hundreds of dams have been removed already in America. Glines Canyon Dam decommissioning, and it was collected from USGS site, and dams are simply broken. Dams are simply broken without taking any precautions, because in their country the rate of sedimentation was not so high. Yet some of the large dams which were removed from the Erosion River between 2011 to 2013 caused the lower catchment areas covered with sediment. Those sediments which were trapped by the dams were brought downstream and covered the large areas. Okay, in India, so let us take the example of Damodar, Mauraksi, and Kamshavati. And if you take the example of Damodars, Maithon, Panchit, Tilaya, and Kunar, they have lost their 30%, 23%, 43%, and 32% respective capacities already in 2016. And after a few years, they have to be abandoned. And if these million, what is the amount of sediment, catchment area, initial capacity, rate of silting, okay, loss of capacity you can calculate. It is the initial capacity. Initial capacity, 30% is lost. So 30% of this is the amount of sediment deposited in million cubic meters. If this huge sediment comes down slope, moves down slope, then what will happen? That may fill or bury or cover downstream channels and downstream riparian areas. All the agricultural fields will be covered with sand. And channel avulsion, channel will shift on those newly deposited sections. And there will be flood because all the water holding capacity of the channels will be already filled by the sediments, covered with sediments. There will be frequent flood. So life and livelihood of the people, downstream people, will be at stake if those dams are to be removed or are to be decommissioned. Check dams are very popular method, and most of the scientists, soil scientists, hydrologists, they always prefer for the construction of check dams. These may be the concrete check dams. These may be the smaller check dams at the initiatives of the farmer. At the level of farmer, they are holding water. They are using this water for cultivations. So these are very popular method for water harvesting in the areas, in the dry areas. In a catchment, smaller channel in Purulia and Bankura, you see how many check dams are say constructed within few meters, within 100 to 50 meters. There are numbers of such small check dams. That means the river is totally blocked after some distance with these check dams. And generally, we believe that those check dams are very effective measures for water harvesting as well as for soil conservation also. Let's have a look. This is one of our work with my scholar Prabhat Kumar Sheet. This is one experimental site we took near our university in Midnapur, where we constructed dams, where we constructed check dams. Before construction, what was the geomorphic situations where source to sink connectivity was very high, bank to channel connectivity was very high, and there was a gentle concave slope. And I'm not going into the very detailed discussion. These pictures will show you the entire things. Then check dams were constructed in the year 2008. And you see, in 2009, entire area is covered with sand, sediment, and that sediment favors the growth of vegetations. And this vegetation again started to trap the sediments. So one positive feedback loop has been set up in this area. Sedimentation favors vegetation, vegetation favors sedimentation, and this thing goes on continuing in a cyclic manner. Okay, and say the slope of the river basin or gradient of the channel has been changed. In June 2010, the situation of this area was like this. In September, after post-monsoon or during just after the post-monsoon, situation was like this. And we tried to quantify or its impact, and soil detachment rate has been reduced drastically by 80%, as well as runoff volume has been reduced by over 28%. And this is how the region was in 2011. And new fresh deposits were also started over the former deposits during monsoon. And in 2018, the situation of the areas are like this. So entire area was covered with the sediments. 2018. So apparently what happened, what we found, that this region is almost stabilized. Okay, but if you inspect very minutely and intensively, then the situation would be just opposite. All the dams, all the check dams acted as the base levels. All are acted as the base level for its upper part, for its upper part. That means the earlier gradation has been lost, and river or the channel try to adjust with the new base level, and further dynamism has been introduced. So this thing we have already discussed. If we took the picture from the opposite side, the entire region looks like this. So you have stabilized this area. Your base level was somewhere at the lower part, and over here at the lower part. Now you have shifted the base level to these areas. These are the dam sites, check dam sites, and now river has to adjust its new profile. River has to cut its new profile. River because this profile is steeper than the graded conditions. Now river has to erode back to make a gentle slope. So that means before stabilization, much erosion is required, and it is obvious. This picture will show you the entire things. These are the position of the check dams. And now the situation of the area. One example I can give you. Look at this. Look at this catchment, small catchment, real catchment, when we are starting to construct the check dams. Now see, in 2009, it was in 2008, and what is its situation in 2009? When erosion has been stopped, sedimentation occurs in the lower part of the channel, but in upper part, near the water divide, erosion is far more. Erosion far more, and it starts to get graded condition to smoothen its slope because the check dams has been constructed here. Look at the position of the check dam. Yes, check dam has been constructed here. That means this slope is now steeper enough. That's why river has to cut its valley further to make a graded one, to achieve a new graded conditions. It is like this. It is how the situation was there. Another example over here. Concentrate to this section. Yes, one says intensive channel has been cut. Now this is graded. Now this is graded. So what happens after the construction of the check dams? Older landforms are there, and new set of landforms were developed over it. That means there are numbers of sets of landforms of different ages. So total say equilibrium or gradations was lost, and a new disconnectivity, sensitivity, and has been introduced, and then new component of landscape. Every new component of landscape starts its evolution at its own. Everyone try to evolve at its own. So there is a chaos now. There is a chaos. So earlier, present landscape. So if we scale up this experience, it is a large gully basin in Gorbeta areas of Paschim Mednipur, and it was the river Shilabati, and this gully catchment meets the river Shilabati in 2003. And you see, in the year 2011, two embankments were constructed, two dams, check dams were constructed, and as a result, water and sediment has been trapped. And gradually, due to sedimentation, these ponds or the small reservoirs are starting to fill, and you see all the channels develop their own say deltas near their estuary. It now acts as the base level. It acts as the base level or lake level, and every tributary contributes their sediment within these say depressions, and they develop their own set of islands, deltas. But in the upper areas, erosion still continues. In the upper areas, erosion still continues. Okay. Those deltas grows further. Look at my cursor. Deltas grows further. These are the deltas extended within the ponds. And now the authority, they constructed gully plugs. These are the gully plugs. Numbers of gully plugs they constructed to restrict erosion. Then what happened? By the construction of gully plugs, all the basin floor has been covered with the sediments. But instead of down cutting, they started lateral erosion. As the valley floor is sealed, they started lateral erosion. Lateral erosion started. Okay, lateral erosion started. channel widens, valley sides eroded. So in this condition, in this situation, if you like to withdraw all the check dams today, then what will happen? All those sediments which were trapped, they will flow downward and they will cover the entire downstream segments. Okay, so problem is much less in case of check dams than the large dams. Now the bridges. We construct bridges. And due to the construction or the construction of bridge, we sometimes constrict the channel to reduce the cost of constructions. It is the Gish River, it is the Chel River. Okay, and these are near Bagrakot. These are near Bagrakot regions. Over the Chel rivers, over the Gish rivers, you'll see how the channels are being restricted, being constricted. And we made one study to see what is the impact of these constrictions. Here it is the original stream of 0.80 meter width, and it was the width depth ratio. And putting boulders, we tried to constrict the channel to almost half of this original one. Let's see. On the original stream, the flow is already tranquil, almost tranquil, where parallel sheets of water flows without making any disturbance or turbulence. Okay. Now we constricted the channel. You see? Yes. Now after constriction, yes, there is the turbulence of flow. So the flow has been turned to a turbulent one, and every character of the river has been changed. Previous velocity was this, altered velocity has been changed. Slope was almost same. Previous depth of flow was there, this 0.08 meter, and now altered depth of flow is this. And we tried to calculate the shear stress in previous situation and present situation. In previous situation, it was the energy, shear stress, and in the present situation, it is the energy. And if we plot all these things on the Hallström curve, it was the original condition of the river. And where river was the transportational river. But as the channel is being constricted, it is now transferred into a erosional one. So scouring the bed, river erosions, all these things will start after you alter the river behavior. So we have to study the river behavior before going to any structural measures, before going for any structural measures. That one, our engineers lack. They didn't make any survey about the river behavior, river systems, fluvial systems before going for any constructions. And they constructed. If capital is available, if other conditions are favorable, then there is no barrier in the constructions. They constructed large dams, they constructed bridges by constructing channels, and then they constructed embankments also without the study of river behavior. How the entire behavior of the river will be what's changed. And now see, by this scouring, there are the deposits, and these depositional lobe keep on increasing, keep on moving downstream, and entire downstream has been affected. Okay. Now if you come to the embankment seems to be very less effective structural control because it doesn't restrict the flow. It is not the obstruction of the flow, but only along the river the embankments are constructed. I can take the example of Indian Sundarban, where embankments were constructed along both sides of the river and the forest was cut by the reclamation process. And let us see how the total estuarine geometry and process has been changed with these interventions. This is the natural system, and during high tide, all the islands and the channels were flooded with this water, and sediment gets deposited, gets distributed over the entire area. And it is the cross-sectional shape of the original stream. But as you put embankments, river is restricted. So flow of water and sediment, both are restricted and both are concentrated within this channel. And one important thing, it is how the geometry has been changed, but how the process has been changed. When under the natural environment, tide water enters into the land, flooding the entire island. And there was the vegetations, mangrove, it's a very deep mangrove, dense mangrove. And when water passes through this dense mangrove, there is high shearing resistance. And velocity of the water is not high. Water cannot proceed inland with a greater speed during tide. So tide velocity is less. But when water drains back during low tide, according to gravity, then flow of water is much more. That means all the sediment which was brought into the river during high tide are all washed away during the stronger low tide. So it was the ebb dominating system, and all the channels, you see, all the channels are so clear. But if you put embankment, then high tide will proceed at a higher speed because of much depth of water. If the depth of water is high, then resistance, frictional resistance would be less, and velocity of the water will be very high. Okay, so flood velocity is high. It could bring huge amount of sediment inside the channel. But when low tide occurs, that water cannot move so fast through these deposits. There are bars, shores like this, lots of deposits are there, and that water cannot drain so much. So the velocity of low tide is so high, so less, so that it is not sufficient for draining all the sediments back into the sea. You see the color of the water, and you see the chores and deposits within the channel. So one ebb dominating system has been entirely transferred into a tide dominating system. So this is what is the permanent damage of the process, estuarine process of Indian Sundarban. And see, if there is more and more deposition within the channel, river bed rises, and river bed is much higher than the surrounding islands. It is the level of the island, and it is the river bed. Let's see how stronger embankment you will create, you will construct to protect these habitations from this embankment breaching. Tapon is here. Tapon did an excellent PhD work on this embankment breaching and on this problem of Sundarbans. And see, there is a tendency of the river to flow over bank, and it is called overtopping. And during this overtopping, this side of the inland side of the island, inland side of the embankment will break. Inland side of the embankment will break, and during the low tide, then opposite side, riverward side of the island will break. So it takes 6 hours high tide, 6 hour low tide. So total within 12 hours, entire embankment will be destroyed. So this is the effect of alteration of the process, entire process that we did. So there are the Isla, Amphan, yes. So we have to see lot more such distractions in the coming future. Now, it is my concluding remark. Before dam decommissioning or before withdrawal of any impact, we have to make a feasibility analysis, detailed feasibility analysis. And all of us, as a geography student, all of us know the EIA, Environmental Impact Assessment. Before the construction of dam, before the construction of any project, before alteration of the natural sites, we have to go for detailed EIA. And again, I will suggest that such an EIA are mandatory before the dam decommissioning. All the dams should not be removed suddenly. There should be the priority scale. We have to set a priority scale. We have to identify more critical dams, and step by step we have to remove them. Entire dam could not be removed. Step by step we have to remove them. And during this EIA, river geomorphologists or river scientists or the geographers are to take their active role. So inclusion of the geographers in this EIA process is a must, because they know the system, they know they can analyze the system in a holistic manner. But what already have been done, what damage have been done, is due to the result of partial study and partial understanding. We must have to understand whole system together. And after the decommissioning, the dam authority should not be abolished. Say there is a DVC. DVC is the dam authority, Damodar Valley Corporation. When you start abolishing those dams, dam authority should not be abolished. They have to be there for monitoring the impacts. And for managing those impacts, their role is very important. Okay, so with this, thank you very much, and I like to give my thanks to the organizers for giving me the opportunity to share my vision with a fantastic audience like you. Thank you very much.
Thank you, sir. Thank you, Professor Maiti, for such an informative and elegant presentation. I hope that the lecture will surely influence our present thinking process towards the river behavior and the restoration process of environment. Thank you so much, sir. Now, without delaying, I would like to call again Professor Shonil Shom to continue with the interaction session with our speaker and the participants. Thank you, ma'am. Over to you.
Thank you, Priksha. And first of all, very, very much thank you to Professor Ramkrishna Maiti for your esteemed presentation and nice explanations too. It was very nice, very informative and very contentful. And I think it will surely help our students too. Because it is very much, the examples are from down to earth, from the ground level, and from your own experience. It's very nice to see and very nice to share all this, and very nice to learn from you, and very nice to hear from you. But yet I am seeing that no questions are written in the chat box, and in YouTube streaming.
Hello?
I think there is no question too, though I am waiting for Devolina. Now I would like to request the participants, if they have any question, they can unmute, they can raise their hand and interact with Professor Maiti, and surely we will help them to interact with him. Ananya, you have unmuted yourself.
Yes,
Do you
ma'am.
want to say something?
Good afternoon, Sonal ma'am.
Yes.
Good afternoon, Professor Maiti. I have a little query. I just want to ask that as far as this restoration is concerned, there are few wetlands over. I live in North 24 Parganas, Barrackpur area. So over the area, there are few
Ananya, you are not audible.
Ma'am, hello, hello, ma'am. Am I audible now?
Yes, yes.
Okay,
Yes, you are audible now.
okay. Sorry for the inconvenience. I have a query to sir that there are few wetlands over uh, on the. I live in Barrackpur. So over here, there are few wetlands were there. Previously, around 5 to 6 years back, the wetlands, the state or the condition of the wetlands was quite feasible. But right now, most of the part had been silted, and there is like prolific growth of like hyacinths and everything over there. So there was fish cultivation was prevailing at that time, but right now everything has stopped. But as far I have seen over the Rajarhat area, Kamduni places, there on the road connecting both the sides, the wetland over there, the water is still quite fresh and pisciculture is still prevailed. Both the areas I'm talking about belong to Rarban area. So, sir, how do you or what are your views relating to how can we cope up with one area, though being still feasibly abided with the environment, but the other is actually deteriorating day by day. So, what sort of eco restoration can be actually implemented over these places?
So very important question, Ananda. Thank you very much. Actually, we have to find out what type of impacts are there. In one area, in Barrackpur area, you told there are huge rate of sedimentations, and from where sediments are coming. We have to identify this, and it may be the deliberate attempt. If it is near the urban areas, and if people are trying to extend their habitation over those wetland areas, and wetland filling and constructions are very common nexus, and there should be the strong say civil societies who will say struggle for the revival of the wetlands or for the restorations of the wetlands. So restoration of the wetland against those forces, illegal forces, are a very difficult thing. But still, there are some areas where the civil societies are working efficiently for the protection of those. Actually, wetlands are treated as the kidneys of the society, mainly the kidneys of the urban areas. Okay, so at first you have to identify the sources of pollutants, sources of sediments, and whether any alternative could be thought of for the disposal of those pollutants or sediments, and then we should go for those alternatives. And on a single day, we couldn't propose that all the industries should be stopped, or all the activities which are occurring surrounding those wetlands should be stopped. We couldn't make any destruction of the economic activities or societal behaviors, societal habits, but we have to find out the alternatives. It is our duty. Everything should continue. The economic activities, employment generations, livelihood activities, societal activities should continue, but without making any harm to the environment. So our attitude would be to find out the alternatives. What people can do without making harm of their activities. Okay, if you propose that all the industries should be stopped, if you draw the attention of Pollution Control Board and those industries are stopped, then lots of people will lose their job. So it is not our motto. It is not our objective. Our objective is to compromise and to improve. There should be some compromisations, and the better alternatives we should select. and we will propose the alternatives, and you can go for that alternative, continue all of your activities. Then only society will accept you. Society will pay attention to your words. Otherwise, all the negative things that the environmentalists and academicians generally propose are not acceptable for the societies.
Thank you, sir. Thank you for saying in a very detailed way. Of course, we need to revive our land ethics also. Not only
of course. Yeah.
that is the main thing. So I think in a prospective way, if we need to inform to the in a very rigorous manner, I think it may work out definitely.
Yeah, of course.
Thank you,
of
sir.
course.
Thank you.
So it is a continuous process, I think. On a sudden day, you cannot change the society. It's a continuous process. You have to write about the impact and importance of the wetland and how those impacts are deteriorating the ecosystem service and which are ultimately affecting us. So you have to write in the local, very local channels, local newspapers, and little magazines. So you have to make your views popular among the society.
Okay, next, Orkodeep. Orkodeep, you have raised your hand.
Yeah.
Yes.
Good afternoon, everyone. Good afternoon, sir. Sir, in lower Damodar region, there are many decaying rivers, sir, which has a glorious past, but nowadays they are in a very dangerous condition, sir. So how can we restore that river, sir?
Actually, decaying of the earlier channels is a natural process. Because the active channel will cut its valley downward, cut its valley more, and those channels which are having less water, they will not be able to keep pace with the main channel. That's why they will be elevated, and less water will flow to those channels, and ultimately those channels will dry out. So if you see the phases of landscape evolution, phases of deltaic growth, then these decaying of the channels are a very natural one. So they are not dangerous one. Don't say this word. They are not in a dangerous conditions. So this is the natural one. But revival of the channels are necessary for the distribution of flood water. When lots of water will come in the main channel, those water during the flood, during the high flow, will be distributed along those channels. That's why we should make those channels clear. There should not be any dams. Actually, most of the dams in most of the channels, there are lots of borobans. Am I right? Lots of borobans are there, and most of the channels have already been choked. Okay, are obstructed. So there should not be any flow obstruction, and let the river to be at their own, and those will be sufficient to carry the excess load during the flood periods. Okay.
Okay, thank you very much.
And then, Orkodeep, one thing you must know, that the river doesn't work every day. Most of the erosional and transportational process are episodic. And if the channels are allowed to have the flood water, then during this flood, most of the channels will be clear of their sediments, and channel will be revived. Okay.
Thank you very much. Thank you.
Okay.
Okay, next, Mridul Varman. Are you there, Mridul Varman?
Yes, ma'am.
Yes.
Am I audible?
Yes, you are audible.
Thank you, all organizing committee, and thank you, research person, sir. I have two questions to you, sir. First one is, when a dam construct without following an EIA process, how to resolve? Sorry, when after we facing many environmental issue, how to resolve this environmental impact issue as per corporation and as a geographer, how we resolve. And number 2 question, as per your research, as per your view, what is the parameter of healthy river bank? This is sir.
So,
Thank
Vidul, you put a very important question. Actually, the large dams, when was constructed, say before 1960s, there was no concept of EIA. And if you see the ages of the dams or the year of construction of the dams, and you will see 80% of the large dams were constructed before that. And we had very little understanding. I have given you the say time frame of the understanding about the environment. Till 1970s, we were not sympathetic to the environment. We tried to collect all the resources out of the nature as much as we can. We never thought of the environment. So most of the amendments were constructed before that. But afterwards, we saw its negative impact. Negative impact will be more when the ages of the dams will cross 50 years or more. Every dam has their life period, say 50 years, 50 to 100 years. So when they cross the 50 years of lifespan, then only we will see their negative impacts. And presently we are having it. So this is beyond the control of the dam authorities. So DVC cannot control the flood. DVC cannot distribute the irrigation water to its entire command area, because these are beyond the control of them. They couldn't control it. Sedimentation is a obvious process, and loss of capacity is an obvious process. Okay, so as a geographer, what we understand that those constructions were not logical enough, and then our attitude to conquer the environment, total conquer the environment was not logical. So we should obey the principles, natural principles, and we should plan our resource use in consequence with the natural systems, in accordance with the natural systems. We shouldn't say totally control the natural systems. Entire control on the natural systems has gave us the setback. Global warming is the setback, isn't it? Then healthy embankment, healthy river bank. Healthy river bank is a relative terms. It depends on river to river. Some river has a tendency to sway back, to move to and fro. It depends on the entire river characters. It depends on the gradient, river gradient, flux of water, flux of sediment, and amount of vegetations. So sediment flux, sediment, discharge, and vegetations are three boundary conditions. These are called flux boundary conditions. These determine the character, dynamic character of a river. Okay, if there is sudden flow, sudden increase of the flow, river may behave differently. And that's what our streams in monsoonal countries are behaving. Due to high rainfall during monsoon, there is huge discharge in the river, and river behaves accordingly like a mad river. Okay, so healthy embankment, a healthy river bank should have gentle slope, should have sufficient vegetation cover. Which kind of vegetation? Not the tree type of vegetations, but the bush kind of vegetations having intensive root systems. So root density should be high, root length should reach up to the bottom of the banks, and this bank sides, riparian sides, at least up to a few 100 meters, should be clear of any human settlement or constructions. So according to me, this is a healthy environment, a healthy river bank. Gradient should be sufficiently less. River bank gradient should be sufficiently less, and then they should be covered with bush type of vegetations having intensive root system and deep root system. And it should be avoid of any human constructions or occupations.
Thank you, sir. I got it, my answer.
Okay. Now I'm seeing Devashish Talukdar, who have raised his hand. Devashish, are you there?
Yes, madam. I have a question to you, sir.
Yes, please.
My question is, can we incorporate river restoration with the river engineering? If yes, then how it will work to improve the hydrologic or geomorphic or ecological processes of any river?
Actually, river engineering is the structural control. These are the structural intervention on the rivers, along the rivers, across the rivers, along the banks. So these are the engineering structures. Okay. So engineering attitude or engineering approach have some limitations. They never think about the entire system. I think most of you can follow the Bengali. আমি একটা বাংলাতে একটা গল্প বলতে চাই। কিছুদিন আগে পশ্চিম মেদিনীপুরের শালবনীতে একটা জিন্দালের একটা প্রজেক্ট প্রপোজাল জমা পড়ে এবং সেই প্রপোজালে nearly 600 million cubic meter of water was proposed to withdraw from river Kongsabuti. তো সেইটা নিয়ে আমি ইঞ্জিনিয়ারদের সঙ্গে কথা বলি যে এমনি রিভার কংসাবতী এবং রিভার শিলাবতী এদের ফ্লো এমনিতেই কম, কিন্তু আপার কোর্স থেকে যদি এত জল তুলে নেওয়া হয় তাতে আরো রিভার মরে যাবে এবং রিভার স্টার্টেড সেডিমেন্টেশন, লোয়ার ক্যাচমেন্টে সেডিমেন্টেশন হলে তাহলে আপার ক্যাচমেন্টের যখন ফ্লাড ওয়াটার আসবে তখন সেটা ক্লিয়ার হতে পারবে না, ফ্লাড কন্ডিশন উইল ইনক্রিজ এন্ড এন্টায়ার এরিয়া উইল বি ট্রান্সফার ইনটু আ ফ্লাড প্রোন রিজিয়নস। তো আপনারা এটাকে কি করে প্রপোজ করলেন? হ্যাভ ইউ মেড এনি সার্ভে এন্ড মেড এনি স্টাডি? ওনারা বললেন স্যার আমাদের এত স্কোপ থাকে না, we don't have any scope like that. What we consider from the source point whether water is available, and what should be the next consideration is what should be constructed, what should be the constructions, whether it is feasible with the capital, and from the destination point whether this can be reached. আমি যেখান থেকে পাম্পিং করব সেখানে আমার জল পাবো কিনা, পাম্পিং করা সুবিধাজনক কিনা, পাইপলাইন পাততে পারবো কিনা, আর ডেস্টিনেশনে এটাকে পৌঁছে দিতে পারবো কিনা। These are only our considerations, sir. Entire system could not be studied by us, and it is beyond our approach and beyond our capacity. So this is what the limitations of engineering approach, and that's why we are having so much limitations, so much negative impacts of all kind of engineering structural engineering works. And I have given you the elaborate discussions about the large dams, check dams, bridges, and amendments. So river restoration means the first step is to withdraw these things. But if we withdraw all the things suddenly, then it will not work. It will be a disaster. Again, it will be a disaster. Okay, so we have to go step by step. And again, we have to go for a detailed study about the impacts, possible impacts. And their holistic system considerations should be there. You have to consider the holistic systems. Okay?
Okay, sir. Thank you, sir, for your knowledge sharing.
Thank you very much.
Okay, thank you, sir. Is there any participant who want to interact further? Choitali Roy, are you there? You want to ask?
Yes, thank you.
Yes, Choitali Roy.
Good afternoon, sir.
Yes, good afternoon.
Sir, I would like to ask you regarding a broader perspective. Sir, if we consider Farakka barrage, there we have seen a lot of changes occurred in downstream and upstream as well. Since the construction of Farakka barrage during 1970s, we have seen a lot of changes occurred in downstream, like bank erosion, siltation, and everything. But if we give the light towards the aim of the commissioning of Farakka barrage for economic purposes, then what should be our approach? I mean, due to the Farakka barrage and due to the water which we are getting through feeder canal, the southern states are getting water, and other economic activities are carried out in the port due to that water which is coming from Farakka barrage. Now, what should we do? Should we think about decommissioning of Farakka? How should we see the situation? Do we have to cope up with this situation, like what is happening in the southern states like Murshidabad and Noida and these districts? Like bank erosion is a severe problem.
Choitali, you asked about a political question. So it is very much related to geopolitics, and our international relationships are quite related with this question. But so far, the impact of Farakka is actually Farakka was constructed for washing the sediments out of the Hooghly rivers.
Yes.
But in post Farakka season, what we found that sedimentation has been increased more.
Yes.
Sedimentation has been increased without having any benefit in this river, which was the first aim for commissioning the Farakka barrage. But we are having water. We are having water out of the feeder canal, no doubt. And the international relationship has been damaged. And position of India in the international community, not only with the Bangladesh, in the entire international community has been worsened due to this Farakka barrage. And in the upper catchment, there is the bondage activities, and river channel has been being shifted. Bank erosion is still there. Huge amount of sediments are there, and sometime there would be the requirement of decommissioning. Say not today, it may be after 100 years. So this much sediment, how could we manage? That is a question to me. Still, I am wondering, the annual rate of sediment is much high.
Yes.
It may be nearly 400 million cubic metric ton per year.
Yes, sir. Actually, all this sedimentation and port trust, they are clearing the sediments. They are
clearing sediment up to the Kolkata port in the downstream areas, and their attitude is to make the navigability, to retain the navigability.
Yes.
Along a narrow channel, there for every vehicle to move, there is a pilot vehicle which will guide them, which guides them to along that narrow channel, which is kept navigable. Entire channel is not dredged. Only a narrow channel is being dredged regularly, and river is kept navigable along that narrow channel only. But entire stream is rigorously being silted off. Okay. So and at the upper catchment of in the reservoir areas of the barrage, there is huge sedimentation every year, and that amounts to not less than 400 million metric cubic ton per year.
Yes.
So if this amount of sediment is being deposited at the upper side of the Farakka barrage every year, then what would be its amount in next 50 years or 100 years, and how could we manage it?
Yes, sir. That is a big question.
Yes, what would be our future?
Participants. Thank you very much to all of the participants for your nice interaction with our person. And I may request Professor Sonal Som to conclude because there is a time limitation. Thank you. Thank you. Please.
Yeah, obviously,
proceed.
sir. I think one of our undergraduate student has raised her hand. We must take her question and then conclude. Yeah, I'm seeing here Shilpa Karmakar who has raised her hand. Shilpa, are you there?
Yes, ma'am, I'm here. Am I audible?
Yes, you are audible.
Thank you for giving me the chance. My question is to Professor Maiti, sir. First of all, I want to thank you, sir, for that lovely presentation. I very enjoyed it. So my question is, you said the dam has its own aging process or the time period. After that, it started depositing things, materials, I mean sediments. So is there any way to, I can say, increase the sustainability of a dam before constructing it?
So, Shilpa, and I think it is the best question of the day. Being an undergraduate student, if you think up to that level, if you can continue your understanding and your way of analyzing the things, I think you will be a great geographer and probably the better geographer than me in near future. So it is the best question. So yes, every dam has their own aging process because they have their own capacity. And before construction of dam, there is calculation of the sedimentations, rate of sedimentations. For constructing each dam, all those calculations are made, and accordingly, the lifespan of the dams are being checked, and profit and loss has been calculated, and then only if profit is more, then only they go for commissioning of the dams. Dams are constructed. So this is the process. Okay. But all the calculations are being wrong afterwards because in most of the cases, actual rate of sedimentations crossed the anticipation rate. যে রেটটাকে ক্যালকুলেট করা হয়েছিল যে এইটা সেডিমেন্টেশন রেট হবে, কিন্তু পরবর্তীকালে প্রকৃতপক্ষে দেখা গেল তার চাইতে বেশি হারে সেডিমেন্টেশন হচ্ছে। কারণটা কি? কারণটা যেটা বললাম, এই যে বেস লেভেল চেঞ্জ, তার ফলে রিভারের যে বিহেভিয়ারাল চেঞ্জ হবে, গ্রেডেড কন্ডিশন লস্ট হয়ে যাবে, তার গ্রেডিয়েন্টটা স্টিপ হয়ে যাবে, সেই স্টিপটাকে সে জেন্টেল করতে চাইবে ইকুইলিব্রিয়াম পাওয়ার জন্য, তার জন্য সে বেশি হারে ইরোশন করবে। এই যে প্রসেসটা, that was not understood. Still, most of the geomorphologists didn't understand this one. Even you will be surprised to know that when I was presenting this, my understanding with the Indian Forum of Geomorphologists, there was lots of questions among the renowned geomorphologists. The things are not clear to us. And it is the geometry, it is the simple geometry. তুমি যদি কোনো অতিভুজের তুমি ধরো tan theta, তুমি tan theta করলে, তার হাইট তুমি সমান রেখেছো, তার হরাইজন্টাল ডিসটেন্স যদি তুমি কমিয়ে দাও, তাহলে কি হবে? তার গ্রেডিয়েন্ট বেড়ে যাবে। এক্ষেত্রেও ঠিক তাই, আমি ড্যাম করে দিয়ে রিভারের বেস লেভেল শিফট করে দিলাম, রিভারের ডিসটেন্স কমিয়ে দিলাম, হরাইজন্টাল ডিসটেন্স কমিয়ে দিলাম, সো এফেক্টিভ গ্রেডিয়েন্ট হ্যাজ বিন স্টিপার। সেই গ্রেডিয়েন্টটাকে সে অ্যাডজাস্ট করতে চাইবে তার লেংথ বাড়ানোর জন্য, তার অতিভুজের লেংথ বাড়ানোর চেষ্টা করবে, সে আরো বেশি করে ইরোশন করবে। It is the simple geometry. That simple geometry is not understood by the geomorphologist. Geomorphologistরা যদি আন্ডারস্ট্যান্ড না করতে পারে, তাহলে ইঞ্জিনিয়ারও আন্ডারস্ট্যান্ড করতে পারছে না। সেই কারণে তারা যেখানে সেখানে কনস্ট্রাক্ট করেছে। And you will be surprised to know, রিভার গঙ্গা বেসিনে প্রায় 800-এরও বেশি রেজিস্টার্ড লার্জ ড্যাম আছে। এখনো there are more than thousands are under construction. তুমি যদি CWC এর ওয়েবসাইটে যাও তাহলে তুমি দেখতে পাবে। তার মানে এত সত্ত্বেও লার্জ ড্যাম কনস্ট্রাকশন হয়েই চলেছে। শুধু গঙ্গা বেসিনের আমি স্ট্যাটিস্টিক্স দিলাম। আর ভারতবর্ষে হাজারখানেক লার্জ ড্যাম আছে যেগুলোর এজ 50 ইয়ার্স এর বেশি হয়ে গেছে। তাহলে আমরা ওগুলোকে ক্যালকুলেট করিনি। আমাদের দরকার জল কিভাবে পাবো নদীতে? ড্যাম তৈরি করলেই শুধু জল পাবো না, রিভারের ল্যান্ড ইউজ এন্ড টোটাল রিভার বেসিন ম্যানেজমেন্ট করে আমি রিভারকে সারা বছরের জন্য প্রবহমান রাখতে পারি। উই হ্যাভ টু গো ফর দ্যাট অ্যাপ্রোচ। যখনই দেখছি লার্জ ড্যাম করে প্রচুর জল আমি সঞ্চয় করতে পারবো না, উই হ্যাভ টু গো ফর ইন্টেন্সিভ রিভার বেসিন ম্যানেজমেন্ট, ডিসেন্ট্রালাইজড স্টোরেজ সিস্টেম। We have to go for decentralized storage system. প্রত্যেক হাউসহোল্ড ইউনিটকেই জল ভরে রাখতে হবে, প্রত্যেক পুকুরে জল ভরে রাখতে হবে, প্রত্যেক গ্রামে জল ভরে রাখতে হবে, প্রত্যেক ছোট ছোট চ্যানেলে জল ভরে রাখতে হবে, খানাখন্দে জল ভরে রাখতে হবে। পশ্চিমবঙ্গ সরকারের একটা প্রজেক্ট আছে জল ভরো প্রকল্প, তারও অ্যাপ্রোচ প্রায় কাছাকাছি একই রকম, কিন্তু সেখানে আরো ইন্ডিভিজুয়াল ক্যাপাসিটিতে জল বেশি করে সঞ্চয় করার, সংরক্ষণ করার চেষ্টা করতে হবে। লার্জ ড্যাম থেকে আমাদের শিফট করতে হবে। Thank you, Shilpa, for your very intelligent question.
Thank you, sir, for answering that.
Okay.
Yes, actually, it was very intellectual question and very nice question.
Yes.
Really, sir. It was actually, this led us to thought provoking that what should we do and what is going to be our future also. We don't think in this manner and this way, and there is a new dimension of our thinking. Really, Shilpa, you pointed out about that, and it's very nice to hear from you, and very nice answer is also given by sir. So we think there is no other participants, and our time is also limited too. So we must wind up our question answer session here, and we will meet again any other platform with sir, and we should have an interactive session also there. Though it's very nice because there is not only the delivering of lecture, the students and the scholars were also very keen interest to interact with sir. So it was very successful, I think. I want to call Priksha ma'am, are you there to conclude the session and continue with your work? Hello Priksha, are you there?
Yes, ma'am. Okay, without wasting any time, I would like to call Professor Keshav Mondal to convey his vote of thanks to our sirs, and followed by that, Professor Tapan Kumar Dash to conclude and attend the end of today's session. Thank you, sir. Over to you. Professor Keshav Mondal, sir.
Thank you, Professor Biswas. So it's my great privilege that I have been asked to convey the vote of thanks in this session. First of all, I would like to my sincere thanks to our principal sir. Actually, our principal sir is always with us for any kinds of problem and any types of development activity. So in this session, our principal sir and our managing committee of our college decided that so many special lectures and online webinars will be organized in each department. So that's why we have opportunity to organize such types of lectures and webinars. So today, I again thanks to our principal sir. Next, I would like to my thanks to our two Professor Dr. Sujit Mondal and Dr. Ramkrishna Maiti. Dr. Sujit Mondal from Department of Geography, Harbour Women's University, and Professor Dr. Ramkrishna Maiti from Department of Geography, Vidyasagar University. So today we have such a nice presentation and such a wonderful type of new knowledge and new thinking, and all the students, our research scholars, and obviously our also teachers, we learn something, and obviously through this knowledge we can carry about our future, and obviously it's maybe in future we have we have now follow this knowledge. So thanks to this professor, and obviously I would like to thanks to our all the all the team of our department. Actually, not only Professor Das and Professor Sonal and I organized the committee. Actually, there are the entire team of our department, our EG department, our PG department, our geoinformatics department. So all of the faculties, I again thanks to all of the faculties, especially Devolina Pandit, Prasanna Sarkar, Anup Sen, Debashri Talukdar, Shamrat Poddar, Riksha Vishwas, Bolay Das, Somujit Ghosh, Dipankar Saha, Avijit Sen, Ashish Bhomik, and Sudip Das also. So once again there is an announcement to everybody that we have an so many special lectures and online webinars in this session. So please, all of the participants, please listen from in 12th July. There is a online webinar is there where Professor P.L. Basurai giving the inaugural lecture, and Professor Lakshmi Narayan Satpathy and other Professor A.R. Siddiqui give their valuable lectures. In the same day, 12th July, the previous lecture was probably starts from 3 p.m. And in the same day, from in the 12th July, from 7:30, there was another lecture by Professor Sorethni Sen Roy from Geography and Regional Studies, University of Miami, USA. Actually, she also interested to give a lecture in our department. Not only that, from 13th July, Professor Bishambar Prasad Sati give us a lecture from 3 p.m. From 14th July, and there is another another type of lecture by related to horticulture and kitchen garden with the help of Department of Environment and Department of Geography. And in 15th, there is another special lecture by collaborating Department of Tourism and Department of Geography. Professor Dilip Kumar Das and other professor also delivered the special lecture on the topic related to tourism. So thank you, all of you, once again. Thank you. I deliver my mic to Professor Biswas.
Thank you, sir. Now I would like to call Professor Tapan Kumar Das to conclude this session. Thank you, sir. Over to you.
Okay, actually, I'm grateful to the both of the actually resource persons, and also thanks to our head of the department, Professor Keshav Mondal, who have given thanks to all of you. And now this session is closed here. Thank you very much. Thank you all. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you.